Hi guys, welcome back to Mathematics for Engineering 3. This is the second section of the second chapter, which is the solving homogeneous linear equation with constant coefficients. Okay, so in the previous video I talked about the linear equations, right? And the when it's homogeneous and when it's not homogeneous. And in this video we are going to be solving the homogeneous linear equation when the coefficients, if you remember, a and x, a n minus 1x until a 0x, if they are all constants. Okay, there are no x, there are no y. Okay, only constants. So in this video we're gonna be looking at the equations in that form. Okay, so let's begin. Here, solving homogeneous linear equation with constant coefficients. Okay, so if you look at this equation, I know it looks fairly familiar with the familiar to you, right? Because it's pretty much the same as the one that you looked at in the previous video, except that the an, these a, they are constants. Okay, so basically they are numbers. They are not functions of x or function of y or whatever. Okay, they are just constants. And here is 0 because it's homogeneous. Okay, so in this video we're going to be looking at this special case of general linear equations. Okay, when it's homogeneous and when the coefficients are constants. Okay, so guys, before we actually solve any equations, let me give you an idea. Okay, first consider y equals e to the mx. Y equal e to the mx when m is a number. Let's say when m is any number. Okay, so guys, what is the derivative of y? Derivative of y is m e to the mx, isn't it? M e to the mx. Okay, the second derivative would be m squared e to the mx, and the nth derivative would be m to the nth e to the mx. Okay, and that is simple, right? Just keep differentiating. Okay, so guys, if you substitute these derivatives into the equation star, you would have that an, right? M e to the mx plus an minus 1 m squared. Oops, sorry, is the nth derivative first, so I need to substitute this in that first. Okay, my bad, sorry. So it's an m to the n e to the mx plus an minus 1 m to the n minus 1 e to the mx plus blah 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 plus m a1 m e to the mx plus a0 e to the mx equals 0. Okay, guys. Okay, let me make it a little clearer to you guys. This is the nth derivative. Okay, which is this guy. Okay, and then you have an minus 1, right? And after that you have the n minus 1 derivative. Okay, which is this guy. And after that, for a1 you have the first derivative. Let me use some other color. You have the first derivative, which is this guy from here. Okay, and here is just y, which is e to the mx from here. Okay, basically I just substitute all the derivatives with the derivative of e to the mx. Okay, Then here I just pull e to the mx out. I would have that here is m to the n e to the mx. Sorry, there's no e to the mx. Plus I would have an m to the n plus an minus 1 m to the n minus 1 plus blah 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 plus a1 m plus a0 equals 0. But guys, this is exponential, right? This is exponential. The exponential is not 0, right? The exponential is not 0. It means that this is true, okay, or this becomes this, right? So this is true or this is true if and only if an m to the n plus an minus 1 m to the n minus 1 plus blah 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 plus an m a1 n m plus a0 equals 0. Okay, and we call this equation characteristic equation. Okay, we call this equation characteristic equation. Okay, guys, let me conclude this for you. First, we look at the nth order homogeneous linear equation when the coefficients are constants. Okay, and then we look at y equals e to the mx. So we substitute, the derivatives of y and y into that equation. Okay, and we have that, this guy equals 0, which means that, but guys, the exponential function can't be 0, which means that, the y here is the solution. Y here is the solution of the star. Okay, y here is the solution of the star, which means that if you put the y in there, the equation star holds, right? Which means that the equation star holds, or y is the solution of star if and only if m satisfies this characteristic function or characteristic equation. Okay, make sense? So in that case, we're gonna look at 3 cases. The first case is when we have the distinct roots. Okay, so to solve this equation, first we need to write down the characteristic equation, which is an m to the n. Okay, you look at this guy, it's the n derivative. Okay, so you get m to the n plus an minus 1, and then it's the n minus 1 derivative, so you get m to the n minus 1 plus blah 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 plus you get a1. This is the first derivative, so you get m to the power of 1. Okay, and then here there's no derivative, so you get just plus a0. That is 0. So first you solve this characteristic equation. Okay, and if the root of this equation, okay, if you solve this equation for m, if all the roots are distinct, which means that they are not equal, okay, they are not the same, Okay, all of them are distinct. Okay, all of them are not the same. Okay, let's say that we have m1, m2, and mn. Okay, let's say that we have the roots are distinct, which are m1, m2 until mn. Okay, so we have that y1 equals m1, y1 equals e to the m1x is the solution. Okay, from this, from this conclusion, right? If it satisfies this characteristic equation, e to the mx is a solution, right? So this is the solution, and m2 satisfies this equation as well. Okay, it's the root of that equation. So y2 in this form is also a solution, and so on. Yn is a solution as well. And as y1, y2, and yn are homogeneous, sorry, not homogeneous, my bad, linearly independent. Why they are linearly independent? Is because they are exponential functions. Okay, and all the m are distinct. Okay, all the m are not the same. Okay, so when y1, y2, and yn are linearly independent and they are solutions, right? So we know that the solution of star is actually the c1 y1 plus c2 y2 plus c3 y3 plus blah 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 plus cn yn. Okay, that is why we need to do the first section, the introduction, okay, to talk about the theorem, because we need to use it here. Okay, that all the y are the solutions and they are linearly independent, so the solution can be written as this linear combination. Okay, so let me sum it up here. First, if you want to solve this equation, first you write down the characteristic equation, and then you solve the characteristic equation. You get the roots, right? You get the solution m. Let's say you have m1 to mn, and assume that they are distinct. They are all distinct. Okay, so we know that these, and these are the solutions. Why? Because from here we know that the root of characteristic equation, if m is the root of characteristic equation, y equals e to the mx is the solution, right? Because it makes this equation star wholes. Okay, so in that case we know that these y are solution, and because they are exponential functions, they are linearly independent, which means that the solution can be written in this form. Okay, so guys, I know it looks quite hard, but it's actually very easy. Okay, you're gonna look, once you look at the examples, you will see that it's fairly easy. Okay, first let's look at this example. This is the simple example. Here is the second derivative, right? So the characteristic equation is, what is it? It will be m squared, right? Second derivative, so it's m squared minus 5, and then the first derivative, which is m, plus 6, okay, no derivative, which is m to the power of 0, equals 0. And then we solve for m. Okay, we solve for the roots. Okay, the roots actually are the solution, okay, of characteristic equation. Okay, so if we solve for the root, we would need to factorize this first, right? So we have m m is what is it? 6 and 1 is, oh no, 2 and 3, isn't it? And then minus and minus. Okay, so we have that m is actually 2 and 3. So we know that y1, which is e to the 2x, okay, and y2, which is e to the 3x, are solution. Okay, and because they are exponential functions, they are linearly independent. Okay, so we have that y equals c1 e to the 2x plus c2 e to the 3x is the solution. That's it. That's done. Easy, isn't it? It's very easy, isn't it? First, you write down the characteristic equation, and then you solve the characteristic equation. If the solutions, the roots are distinct, okay, 2 and 3, they are distinct, right? Because 2 is not the same as 3. They are distinct. So you have that e to the 2x and e to the 3x are solutions and are linearly independent. So the solution is c1 e to the 2x plus c2 e to the 3x when c1 and c2 are constants. Okay? Is that good? Okay? So let's look at another example. Here, guys, the characteristic equation will be m cubed plus 2m squared minus 3m equals 0, right? Right, because it's the third derivative, second derivative, and first derivative. Okay, so we have m to the power 1 to the power 2 to the power 3. Okay, and then we solve this equation. I pull m out, so I have m squared plus 2m minus 3 equals 0. And then it's m, 3, 1, and plus minus equals 0. And so we have m, which is 0, 1, and minus 3, which are all these distinct. Okay, they aren't the same. Okay, you can see they aren't the same. Okay, it's in the first case. Okay, they are all distinct, which means that, okay, the solution is y equals c1 e to the 0x plus c2 e to the 1x plus c3 e to the minus 3x, or c1 e to the 0x is actually 1, isn't it? Okay, so here is c1 plus c2 e to the x plus c3 e to the minus 3x, and that's it. That's done. Very easy, huh? Okay, cool. So the next example. Okay, before we do the next example, I want to take you back to secondary school when you were in Mathayom 3. Okay, you need to do synthetic division. Okay, and I'm not sure if you remember synthetic division. So guys, can you factorize this equation? Okay, because when you write down the characteristic equation, you need to be able to solve that characteristic equation, right? But if you have like a really high order characteristic equation, you would have the problem factorizing it, right? So one of the techniques that you can use in order to factorize a polynomial is to use the synthetic division. Okay, so let me remind you of the synthetic equation. Guys, if any of you watch this method and you don't understand, you can just come and talk to me, okay? But I think you guys have already seen it before. 1 and 12. So the first step is to write down the coefficient. So here the coefficient is actually 1, right? And then it's minus 1 here, and then it's minus 13 plus 1 and plus 12. Okay, so first you write down all the coefficients, okay, and then you try to guess this number. You try to guess this number, and the process that first you pull this out, you pull this down, which is 1. Okay, you pull this down, which is 1. Sorry, and pull it down here, which is 1. And then you multiply this to this to get this number. Okay, and then you plus, you get this number. And then you multiply this to this, you get this number. And you plus, you get this number. And you multiply this to this, you get this number. And you plus, you get this number. You multiply this to this, get this number. And then you plus, you get this number. Okay, it's the same process, on and on, go on and on. Your aim is that you want the last number to be 0. Okay, that's your aim. Okay, let's do it again, okay? First, you pull this number down, which is 1. Okay, and then you want to guess this number. So that first you multiply this to this, you get this. Okay, and then you take the sum, you get this value, and then you multiply it again, you get this, you sum, you get this value, you multiply it again, you get this, you sum, get this value, you multiply it again, you get this, and you get this value, and you want this to be 0. Okay, so let's try, okay? First, I don't know which one is correct, okay? So let's try, when you do synthetic division, actually there's a theorem, okay, about like what numbers you should use, but I'm not gonna be talking about that, okay? So I'm gonna just keep guessing. So first I'll just get 1. That will be the good guess, right? If you don't know what to guess, it will be 1, 2, minus 1, minus 2. Okay, to begin with. Okay, so if I guess 1, first I multiply this to this, I get 1, right? Right? And then let me use some other color. I get 1 here, and then take the sum, I get 0. I multiply 1 to 0, I get 0. Okay, multiply this to this, I get this 0. And then I get minus 13. And then I multiply, I get minus 13. And then I get minus 12. And then minus 12. And then, bingo, I get 0 here. Honestly, I don't know it's 1. To be honest, I don't know it's 1. Okay, but it's the first guess. I think all the people would guess 1 as well as the first guess. Okay, so if it's 1, you will know that this star can be factorized as x minus 1. Okay, is x minus this number. Okay, so guys, if you get 1 here, it's gonna be x minus 1. Okay, and these become the coefficients of the m. Okay, guys, sorry, the variable is m, so I get m minus 1. So I will get m squared 1 m squared plus 0 m plus, it's not m squared, it's m cubed. Okay, why? Because here is m to the power of 4. Okay, after the synthetic division, the power will be reduced by 1. So from 4 it will be 3. So it will be m to the 3 plus 0 m squared minus 13 m and then minus 12. Okay, and I'll write again as m minus 1 m cubed minus 13m minus 12. Okay, and if you want to factorize this, you can do the synthetic division again. Okay, let me make this a little smaller. Okay, it's too big. I just put it there. Okay, and I do the synthetic division again for this guy. Okay, so the coefficient would be 1 0, guys, because we have 0 m squared. Okay, so you need 0, and then minus 13 and minus 12, and then I'll guess another number. Okay, I guessed 1, right? So the second one let's guess 2. Okay, let's guess 2, and then I pull this 1 down. Okay, 1 times 2 is actually 2, isn't it? And then here you get the plus, you get 2 here, and you get 4, you get, what is it, minus 9, you get minus 18, and that is minus 30, which is not 0, which means that you can't use 2. Okay, so let me go back, you can't use 2. Okay, we have 1, let's try minus 1. Okay, first I pull this 1 down. Okay, and then 1 times minus 1 is actually minus 1. So here you plus is actually minus 1, and then 1 and minus 12, and then plus 12, and then 0, bingo. Okay, so guys, this m cubed minus 13m minus 12 is actually m minus 1. Okay, it's always, guys, it's always m minus this number, so it's gonna be m minus 1 times 1 m minus m squared, sorry, minus 12. Okay, these are from the coefficient here. Okay, it's 1 minus 1 and minus 12. Okay, so guys, from here I can say that is m minus 1, m plus 1, and m squared minus m minus 12, and then I can factorize it as, what is it, m 4 3 minus plus, right? So this guy can be factorized to this. Cool. Oh guys, again, I told you two days ago I went to the unit 4 the exam, right? And I think I text to the live group that there's somebody committed somebody committing the suicide, right? I'm not sure he or she jumped down off the building, right, and die, right? Guys, if you are very stressful, okay, you have any problems with the study, especially this course, okay, come and talk to me. Okay, don't hurt yourself. Okay, don't jump out of the building, that won't help. Okay, there's an easier way to solve it, so just come and talk to me. Okay, all the problems can be solved. Okay, I'm here to talk. Okay, so don't do that. Okay, because I was so afraid, because that day was the day that my students in calculus 1 had the exam, so I was afraid that it could have been one of my students, and that would be really sad. Okay, I asked some students about that. Some of them went to the scene straight away. after they heard the news. Okay. Oh, to talk about that, I've got a friend named what's his name? Bert. That's a good friend of mine. His name is Bert. Uh, he is what we call Taimu, right? Taimu. Taimu is for some of you who don't understand Thai, Taimu is a guy who would love to go to the scene when there's an accident or those kind of things. Okay, so he's a real Taimu. Okay, he's a hardcore Taimu. And one day in the Kasetsart junction, the junction at the Kasetsart University, there was an accident, and Bert, he saw the accident, and he was walking into the junction, but the scene was so crowded. Okay, there were so many people at the scene. Okay, it's so crowded, and he couldn't get you know close to the scene. But he heard people saying that, oh, it's so sad because she was pregnant. Okay, and she was hit dead by a car. That was so sad. She was pregnant, and because Bert, he loves these kind of things, right? He's a hardcore Taimu. So he was trying to get closer to the scene to see the accident, but he couldn't. Okay, so he told all the guys there. He keep shouting, guys, give me the way, give me the way. I am her husband. I am her husband. Because he heard, right? He heard that she was pregnant, and she was hit by a car. So she was ran over. She was run over by a car. So he ran into the scene, saying that guys, I'm the husband. So the crowd were looking at him and gave him the way. Okay, so when he ran closer to the scene, when he saw the scene, it was a dead dog. Okay, it was a dead female dog, but she was pregnant. Okay, and she was hit by the car. Okay, anyway, just to tell you the story to make things less stressful. But guys, this is true. If you have any problems, just come and talk to me. Okay, cool. Guys, let's look at the next example. Here, solve this equation. So first, you need to write down the characteristic equation, which is what is m to the 4 minus m cubed minus 13 m squared plus m plus 12 equals 0. Okay, and then you need to solve this equation, right? But guys, I have already factorized that equation here. Okay, so I'm gonna use the result from gonna use the result from the previous example. Come on, sorry. I need to copy it again. Okay, so guys, it's important that you can factorize any polynomials. Okay, otherwise you can't really do this computation. Okay, so m is, what is it? Minus 1, 1, minus 3, and 4, right? So the solution is c1 e to the minus x plus c2 e to the x plus c3 e to the minus 3x plus c4 e to the 4x, and that's it. That's it. Okay guys, the next question, find a particular solution of this where you have three conditions. Okay, first we would write down the characteristic equation, right, which is m cubed minus 2m equals 0. Okay, this is the third derivative and the first derivative. So we have m cubed minus 2m equals 0. And then we pull m out. We have m squared minus 2 equals 0. Okay. And 2 is actually square root of 2 squared, isn't it? So is m minus square root 2 and m plus square root 2 equals 0. Guys, don't forget this is from the formula a squared minus b squared and a plus b and a minus b. Okay, we look at m as a and square root 2 as b. So we obtain this factorization, and in that case we have that m is 0, square root 2 and minus square root of 2. So our solution is c1 e to the x, okay, c1 e to the 0x plus c2 e to the square root x plus c3 e to the minus square root x. Okay, so we have that y is actually c1 plus c2 e to the square root 2x plus c3 e to the minus square root 2x. Okay, so guys, we now obtain the general solution, right? Okay, let me delete this formula. Well, and they ask us to compute the particular solution. It means that we need to specify c1, c2 and c3, right? But we have these three conditions, right? So first, how about I compute y prime? Y prime would be square root 2 c2 e to the 2x plus it will be minus square root 2 c3 e to the minus square root 2x, right? And y double prime would be this is square root of 2. So you have square root of 2 square root of 2, and that is 2 c2 e to the square root 2x minus that would be plus 2 c3 e to the minus square root 2x. So we would get the, when we use these three conditions, the first condition is what? Y0 is 0, right? Y0 is 0, which means that 0 is c1 plus c2 plus c3. Basically, we put x as 0 here and y is 0. So we have 0 equals c1 plus c2 e to the 0, right? 0 times square root 2 is 0. So it's e to the 0 is 1. Okay. And we have 3 square root 2 equals square root 2 c2 minus square root 2 c3. Okay, can I write it like this? 0 c1 plus square root of 2 c2 minus square root of 2 c3. Okay, and the last one is minus 2, isn't it? And we have 2, we have 0 c1 plus 2 c2 plus 2 c3. Okay, So we have the system of equations, right? So we have three equations, three variables. So we can solve for C1, C2, and C3 pretty easily, right? Right. Okay. I'll solve this one for you, but I won't. Okay, I won't. Just solve it. Using the variables elimination. That will be too long. Okay, I'll use a Kramer or Kramer. I think you guys know it from high school when you did metrics. Okay, so I'll copy it to the next page. So first, if I write this in terms of metrics, what would it be? It would become 0, 3 square root 2 minus 2 equals 1, 1, 1. 0 square root 2 minus square root 2 and 0, 2 and 2. And then here we have C1, C2, C3. Okay. You can look at this form as B equals AX. Okay. And from what we call Kramer rule, we have that C1 is actually determinant. Basically, you put this one, you substitute the first column by B. Okay. So what we have is, guys, this is the first column. So we basically substitute the first column by B. So we have 0, 3 square root 2 minus 2, and then 1 square root 2, 2, 1 minus square root 2, 2. And then divided by determinant of A. Okay, that is simple, guys. That's from high school, Mathayom 5, the Kramer's rule. Okay, when you did metrics, right? How to solve the system of linear equations. Okay, so I'll find this determinant. Normally, you would need to put another 2 column here, right? Oops, sorry, 2 and 2, and then you do this, right? But guys, I won't do that. It's too long. I would do this. The first one, what is the first one? It will be 0, isn't it? It's here, this guy. 0 times square root 2 times 2, that's 0. The second one would be this times this and then times this. Okay, instead of write this here, you don't need to. You can just look at this and then you go here. And then you go here 1, you get the other 2 here. Make sense? Again, guys, down, down, and down. Okay, again, down, down, and down. Okay. So the second one, if you're comfortable with getting another 2 columns, you can do it. Okay, it's up to you. Get these 2 columns and then get down, down, and down. But it's the same thing. It's the same as that. See, it's a lot faster. You don't need to copy and paste 2 columns. So here, what we have is 0. The next one would be 1 times minus square root 2 times 2. That would be plus 2 square root 2. Okay, the third one would be here, this one and the other 2 here. So that would be 6 square root of 2. Okay, and here goes up is minus 2 square root of 2, but it needs another minus, right? So it's plus 2 square root of 2. Here, made here, that's 0. Okay, and then here, that is That's actually 6 square root of 2, right? But it multiply up, so it's minus 6 square root of 2 of this divided by that a. Okay, and guys, here cancel out, so we have that it's 4 square root 2 divided by that a. But guys, again, if we want to find that a, what is that a? That a is the determinant of this guy, right? So the first one would be this, which is 2 square root of 2. Here 0, here 0. See, here 0, here minus 2 square root of 2, but it multiply up. You need another minus, that would be plus 2 square root of 2. Okay, here 0, this is plus 2 square root of 2, and this is 0 as well. Okay, so this is, what is it, 4 square root of 2, which means that the C1 is actually 4 square root of 2 divided by 4 square root of 2, which is 1. So we have that C1 is 1. Okay, and C2 is, what is it? C2 is determinant of 0, 0. For the first one, for C1, you put this, you put the vector b in the first column, right? For C2, you put this vector b in the second column. So we have 0, 3 root 2, and minus 2. And the third column is the same. Minus root 2, 2. And then divided by that a. Okay? So here is 6 square root 2. Here is 0. Here is 0. Okay? Here is 0 as well. Here is 2 square root of 2, but you need to get the minus sign. Okay, and then divided by that of a, which is 4 square root of 2 divided by 4 square root of 2, which is again 1. So C1 is 1, C2 is 1. How about C3? C3 is the same, guys. Is 1, 0, 0, 1 square root of 2, 2, and then you substitute the third column by b, which is this guy, and divided by that a. Okay. See, this is the second, this is the third. So the first one would be, what is it? Here, minus 2 square root of 2. Here, 0. Here, 0 as well. Okay, 0, 0. Here, multiply up, 0 as well. Here, minus 6 square root of 2. And this is 0 as well. Divided by that a, which is minus 8 square root of 2 divided by 4 square root of 2, and that is 2, right? Because here cancel out, we get 2. So in that case, we know that C1 is 1, C2 is 1, and C3 is 2. So we know that the solution is y equals, we have here, right? This is the solution. Okay, so C1 is 1. So we have 1 plus C2, which is 1 as well, e to the square root of 2x. And then plus C3, which is 2 e to the, oops, here is square root of 2, okay, minus square root of 2x, and that is a particular solution. Okay, oops, sorry, this is minus 2, my bad, sorry, it's minus 2. Okay, and that is the particular solution. Cool. Okay, guys, you can try this yourself, okay, and as an exercise. try it, and we're gonna do that in the live class. Okay, gonna solve that problem. Cool. And that is how to solve the homogeneous linear equation when the coefficients are constant. The first case, when all the roots of the characteristic equation are distinct. Okay. Next, we're gonna look at the case when the roots are complex numbers. Okay, guys, don't forget, when we solve the characteristic equation, we can obtain the complex roots, right? So let's say if the characteristic equation has a complex root, m equals a plus bi when a and b are real numbers. Okay, so guys, from complex number that you learned from high school, you know that if a plus bi is the root, we know that the its conjugate, which is a minus bi, is also a root. Okay, if a plus bi is the root, a minus bi is the root as well. Okay, that's the property of complex numbers. Okay, so the solution is this, isn't it? Is C1 bar. Okay, C1 bar is just C1, okay, it's just constant. But I call it C1 bar for a reason, okay? But just think of it as a constant. So C1 bar e to the a plus bix plus C2 bar e to the a minus bix, right? This is M1, this is M2. Okay? Okay, it's the same as in the previous section. Okay, but from Euler identity, we know that e to the I theta is actually cos theta plus I psi theta. Okay, that's the property of this. It's called Euler identity. So whenever you see e to the I theta, it's actually cos theta plus I psi theta. It's the same value. Okay, so the y here is, you know that you can pull can split it, right? So I just split it. C1 bar e to the a times e to the bix, okay, ax and bix, plus C2 bar e to the a times e to the minus bix. Okay, and in that case, you can pull e to the a out, so you would get C1 bar e to the bix, and guys, if it bix, can I write it ibx? It's the same thing, isn't it? ibx and plus C2 bar e to the minus ibx. Okay, and in that case, we have that here is e to the a C1 bar, and that will be cos bx plus I psi bx. Guys, don't forget, here is e to the I theta. Okay, let's look at bx as theta. Okay, so you get cos bx plus I psi bx. Okay, and for the other term is plus C2 bar cos minus bx plus I psi minus bx. Okay, for this one, we look at minus bx as theta. Okay, theta is minus bx. So you get cos minus bx plus I sine minus bx. But guys, from trigonometry, we know that cos of minus theta is the same as cos theta. Okay, and sine minus theta is actually minus sine theta. Okay, so here we have that is actually e to the a c1 bar cos bx plus c1 bar I sine bx plus c2 bar cos bx plus it will be minus I minus c2 bar I sine bx. Okay, we use that property. Okay, so we have that this is e to the a, and then we have here c1 bar plus c2 bar cos bx, okay, plus c1 bar minus c2 bar sine bx. Okay, but guys, because c1 bar and c2 bar, they are constants, right? So I'll just call c1 equals c1 bar plus c2 bar, and c2 equals c1 bar minus c2 bar. Okay, okay, so this one is actually e to the a c1 cos bx plus c2 sine okay. How about I let c2 be I c1 bar minus c2 bar. Okay, so this guy becomes c1 and this guy becomes c2. Okay, okay, so the solution y when we have the complex root is actually e to the ax c1 cos bx plus c2 sine bx. Okay, so let's look at some example like this one. We have that the characteristic equation is m cubed minus m squared minus m minus 2 equals 0. Okay, okay, and in that case we need to do the synthetic division, and it's here is minus 2 and minus 2. So let me use 2. Actually I know it's 2. Okay, oops, it's not. Just 1 second, sorry. What's happening? Okay, here we go. So I actually know that it's 2. Okay, so I pull 1 here times 2 times 1 is 2, and then I get 1 here. 2 times 1 is 2, and then I get 1, and then I get 2 again, and I get 0. Okay, so I know that this can be written as m minus 2 and m squared plus m plus 1 equals 0. Okay, okay, so for this one I know that m equals 2. Okay, and for this one is m squared plus m plus 1 equals 2. From the formula m would be minus b plus minus square root b squared minus 4ac divided by 2a. You remember this formula, right? When a, b, c are the coefficients of the m squared, m, and constant respectively. Okay, so m is minus 1 plus minus square root b squared is 1 minus 4 divided by 2, and that is minus 1 plus minus square root minus 3 divided by 2, and that is minus 1 plus minus square root 3i divided by 2. So guys, we have 3 solutions. Okay, the first one would be y equals e to the 2x, and that's it. Okay, and for this pair a plus or minus bi, right, we get y, which is, what is it, c1 e to the it's e to the a, right? So guys, let's look at this solution. M is actually minus 1/2 plus or minus square root of 3 divided by 2i. So we know that a is actually minus 1/2 and b is actually square root 3 divided by 2. Okay, cool. So the solution y is c1 e to the 2x, which is from this. Okay, which is from this, and then the other one would be, what is it, e to the ax, which is minus half x, and then c1 cos bx, which is this guy, plus, I already used c1, so here needs to be c2, plus c3 psi square root 3 divided by 2x, and that's it, the solution. Make sense? Because guys, as we know, if the solution is a minus bi and a plus bi, we know that the solution is y equals e to the ax, c1b cos bx plus c2 sin bx. Okay, and here the solution is this, so we know that it's a plus bi and a minus bi. So the solution for that is e to the ax, which is this guy, c1, but I already used c1 here, so I just use c2 here. Okay, c2 cos bx plus c3 sin bx. Okay, and that is the solution. Okay, let's look at another example like this one. The characteristic function would be, what is it, m to the 4 plus 5m squared plus 4 equals 0, isn't it? Okay, so guys, let's look at a as m squared. So I have a squared plus 5a plus 4 equals 0, right? I look at m squared as a. Okay, to make it just easier to look, you don't need to do this, okay? You can just keep working with m squared, but it's just a little bit easier to look at. So I factorize this guy. I will get a 4 and 1 plus and plus, which means that I have m squared plus 1 and m squared plus 4 equals 0. which means that m squared plus 1 equals 0 and m squared plus 4 equals 0. And that means m squared equals minus 1, or m is plus or minus I. Okay? Okay, it plus or minus square root minus 1, which is plus or minus I. And m squared here is minus 4. So m is plus or minus square root minus 4, which is plus and minus 2i. Okay, and that is the solution. Okay, so the solution is y equals first when it plus and minus I, it means that a is 0 and b is 1, right? It's actually 0 plus or minus I, right? So a is 0, b is 1. Okay, and when is plus or minus 2i, it means that again a is 0 but b is 2. Okay, so y is, for the first one, okay, for the first one, y is e to the a, e to the 0x, right? c1 cos bx, which is cos x, plus c2 sin bx, which is sin x. And that is for the first root, which is this. For the second root, it would be, what is it? Plus e to the 0x again. c1, okay, I need to use c3, okay, because c1 and c2 are already used. Okay, they have been used. So cos 2x plus c4 sin 2x, okay, which is equal c1 cos x plus c2 sin x plus c3 cos 2x plus c4 sin 2x. And that is the solution. Right, guys, don't forget e to the 0 is actually 1. Okay, so that is the solution. Okay, so to sum it up, if the root, if the roots are distinct, the solution would be constant times e to the mx, right? Constant time, the sum of constant times e to the mx, blah blah blah. If the root is a complex number, which is a plus or minus bi, right? A plus minus bi. It means that the solution is a to the e to the ax times c1 cos bx plus c2 sin bx. Okay, so this is what you need to memorize. Okay, we have another one case. It's the last case, which is when we have repeated roots. Okay, when we have repeated roots. If we have repeated roots, let's say that, let's say we have m star for k times. Okay, we have m star, m star, m star. It can happen that, right? It can happen, right, when you solve the characteristic equation and the roots are the same. Okay, it will be clearer when we look at the example, but you know that it's possible that we get the repeated roots. And let's say if we get m star for k time, we know that e to the m star x, e to the m star x, e to the m star x, they are not linearly independent. Why? Because, guys, they are the same. You look here, they are exactly the same. So if they are the same, they are not linearly independent, right? Because you can pick For example, if you look at c1 y1 plus c2 y2, they are the same, right? So it's the same as c1 y1 plus c2 y1, right? Because y1 and y2 are the same. So you can pick c1 as 1, c2 as -1. So this guy can be 0. Okay, even if all the c are not 0, which means that they are not linearly independent. Okay, so we can't really write the solution as this, as the same as when we have the distinct roots. But one can show that, these are solutions. Okay, I'm not gonna prove that. Okay, if you are interested in the proof, you can look into the proof in the book. Okay, so basically, if you have repeated roots, this is the base solution, and you can multiply the base solution by x if you have 2 repeated roots. If you have 3 repeated roots, you multiply the base solution by x squared, and you get 3 roots, and so on. Okay, so we know that if we have k repeated roots, we have that the solution is c1 e to the m star x, c2x e to the m star x, c3x squared e to the m star x, and blah blah blah. Okay, and those is the combination is going to be the solution of star. Okay, let's look at examples. Like for example, this one. The characteristic equation is m to the 5 minus 3 m to the 4 plus 3m minus m squared equals 0. So which means that I can pull m squared out. So I get m to the 3 minus 3m squared plus 3m minus 1 equals 0. Right? And in that case, I would need to, I don't need to. If you remember this formula, a minus b cubed, that is a cubed minus a squared b, no, 3a squared b plus 3ab squared minus b cubed, right? In this case, if you look at a as m and b as 1, so you can see that it's actually m squared and m minus 1 cubed equals 0. Okay, which means that we have m equals 0, 0, 1, 1, and 1. Okay, because we have m squared equals 0, right? It means that m is actually 0, but there are 2m. Okay, so we have 0 and 0. Okay, guys, if we split this, we would get m equals 0, m equals 0, m minus 1 equals 0, m minus 1 equals 0, and m minus 1 equals 0, right? And that result in repeated roots. Okay, so the solution is c1 e to the mx, which is 0x, plus c2, but instead of using e to the mx 0x, we need to put another x here, okay, to make it linearly independent. Okay, so the next one would be plus c3 e to the x, okay, which is 1x, plus c4x e to the x plus c5x e to the x squared e to the x, and that is the solution. It's so easy, isn't it? Okay, what you need to remember, what you need to memorize is the forms. Okay, we have 3 cases. Okay, distinct roots, complex roots, and repeated roots. Okay, for the repeated roots is really similar to the distinct root. It's just that if the roots are repeated, you need to put x squared, x cubed, and blah blah blah. Okay, to make it linearly independent. Okay, let's look at another example. Here, the characteristic equation is m to the 6 plus 2m to the 4 plus m squared equals 0. And of course, I would pull m squared out, so I get m to the 3. M to the 4 plus 2m to the 2 plus 1 equals 0. Okay, guys, and whenever the trick is that whenever you see m squared and m to the 4, okay, without m to m cubed, okay, without m cubed, it's likely that you can let a be m squared, and in that case this guy is a squared plus 2a plus 1, and it can be factorized to a 1 1 plus plus, and that is, what is it, m squared plus 1 and m squared plus 1. So here we have m squared and m squared plus 1 squared. Okay, so we have that m is 0 for m squared. Okay, so we have m squared plus 1 equals 0, which means that m is actually plus or minus I, right? Okay, let go a little slower. M squared is minus 1, which means that m is plus or minus square root minus 1, which is plus or minus I. And similarly, we have m squared plus 1 equals 0. Don't forget, guys, we have two of them. So we also have m equals plus or minus I. Okay, so here we have 6 roots. Okay, we have 6 roots. So the solution y would be c1 e to the 0x plus c2 x e to the 0x. Right? Because these are repeated roots. Okay? And again, guys, when we have m is plus or minus I, we know that a is 0 and b is 1. Okay, so here we have plus e to the 0x, okay, cos x plus psi x. Okay, cos x plus psi x. And then we have another plus or minus I, which means that we would get e to the 0x, and then you get one more x, guys, and cos x plus psi x. Oops, I forgot the constant, my bad, sorry. Get c3, c4, and here we have we can have c5 and c6. Okay, so see, we have 3 cases. That's it. That's the end of the solution. So we have 3 cases. We have repeated roots and we have the complex roots. Guys, the complex roots can be repeated as well. Okay, like this, right? We have plus or minus I twice. See? So when we have plus or minus I twice, it means that we begin with plus or minus I first. So we get this one. And then we get another one, right? We just put x here. Okay, it's the x times the base solution. but this is the base solution. Okay, it's like this one is the base solution, right? For the next one is x times the base solution. And similarly, if we have plus or minus I twice, we have the base solution, and then we have x times the base solution. Okay, and that's it. That is the okay. Let make it look a little better. So here it would be, what is it, c1 plus c2x, right? Because e to the x is e to the 0x is actually just 1. Okay, and here is 1 as well, here is 1 as well. So how about I group them together like this: plus c3 plus x c5, or maybe c5x cos x plus c4 plus x c6 psi x, like that. I think that looks a little more beautiful. Okay, and that's it. That is the solution for the equation. Okay, so guys, that's it for this section. Let me sum it up. In this section, we solved the homogeneous linear equation when the coefficients are constants, right? And in order to solve that, we look at 3 different cases. The first case is when we have distinct roots, the second is complex roots, and the third is repeated roots. Okay, but guys, don't forget the complex roots can be repeated. Okay, so if we have the distinct roots, we just, the solution is just y equals c1 e to the m1x plus c2 e to the m2x, blah blah blah, when m1 m2 m3 blah 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 are the roots of the characteristic equation. Okay, when we have the complex roots, the solution is, what is it, e to the a, the complex, when m is a plus and minus bi, right? The complex root, so the solution would be e to the ax, okay, e to the ax times c1 cos bx plus c2 psi bx. Okay, and if we have the repeated roots, okay, the solution is, you get the base root first. Okay, let's say if the base root m is 1, so we get c1 e to the x. Okay, if the base root is 5, so you get c1 e to the 5x. Okay, if the base root is a complex number, let's say 1 plus and minus I, so the base solution would be e to the x, right? And then you have c1 cos x plus c2 psi x. Okay, and that's the base solution. And it depends on, how many times the solutions are repeated, right? So you multiply the base solution with x, okay, and you get another solution. And then if it's repeated more than 2 times, you multiply that solution by x again, you get another solution. Okay, and that is simple. Okay, guys, I think this chapter is actually a little easier than the first chapter, right? Because the first chapter is so, there's so many techniques, right? And you need to be able to look to be able to determine which techniques you want to apply to a particular equation. But here is simpler, right? It's only one technique. Okay, you need to write down the characteristic equation, solve it, and then you get the roots, and then you have 3 cases. Just do it as it is. So this one is pretty simple. Okay, keep doing exercises, guys. Keep doing exercises. If you have any questions, just come and talk to me. Okay? So bye for now, guys. Thank you for listening. Bye bye.